What countdown? What countdown? No countdown, because this is the Ham Radio Crash Course. What's everybody? What's up, indeed? Crazy week as always. Oh, I get to exhale now. The stream is like my welcome to the weekend. Welcome to the weekend. Everything's going to be okay. Anyway, here we are, another Friday, continuing the general class license. As always, we got some news to get out of the way. We're moving forward with radio as I start off every one of these streams with. What that means is we start with what we know, and we just keep building and building and building. And sometimes that means reading out of a book like this one, like our textbook that we're reading out of it. Some of it's going on Google, some of it's going on the YouTubes and all the other fun stuff. The point is, you're learning, you're getting out there, and you're trying. You got to try, and then you learn, and you try, and you move, and you just keep moving up. Okay. Case in point, my antenna issues, which I talked about, ended up ordering a MFJ tuner, which should be arriving soon, hopefully, to put in between my radio, which interfaces with my radio, so it's an automatic tuner. Didn't think that necessarily the 7300 wouldn't be able to tune up the G5RV, but at the same time, it's probably too much of an expectation for the 7300 to do that. Got a lot of people in the chat showing up right now. 86DM Dennis, what's up? Carrie's there. Hey, Carrie, how you doing? David Nimi? Hi from Ottawa, Canada. Awesome. I've got a pencil. Give me something to write on, man. That's, school's out, right? Or no, that's David Lee Roth, right? Yeah. So I don't know if you noticed, but it's quiet. It's so quiet. The kids are at Disneyland with my wife, so we will have the entire house to ourselves today, which is great. A couple things to remind everybody about: the Ham Radio Crash Course on Facebook. The newsletter's coming out next week for May. That's a Patreon thing. So go check that out. Links in the description. The beer of the day is the Sukaba, which I'll tap into in a second. It's a barley wine ale. Very excited about that. And yes, I just pulled it out of the fridge and put it back in the box so I could be all fancy and show you. I want to do a new segment. I want to do Ham Shack of the week, Ham Shack of the month, whatever. So if you have a picture of your radio, even if it's just a simple setup, even if it's just you in the backyard with a simple antenna connected to your VHF, UHF handy talkie, awesome. Show me it. How you do that, go to the Ham Radio Crash Course on Facebook and show it to me that way, okay? And we'll pick something, we'll do a vote, and we'll have a winner. We'll pick a winner, all right? Let's see, what else is going on? It's international. Well, it's not international. It's Morse Code Day, okay? So, started out with a little bit of Morse code in the background there off the 7300 listening. If you're not already, I'm going to switch things over really quick to the web. This is the Zen and the Art of Radio Telegraphy. If you haven't gotten this link before from one of my previous streams, go check it out. It's a free download. It's a good book on getting you kind of in the mindset to learn CW. Hey, Lamb Dog's there. Got work tomorrow, so hit the sack. Hey, thank you, Lamb Dog. Check-in has been noted. Right on, man. 7-3. Okay, so go check out the Zen and the Art of Radio Telegraphy. It's very cool. Totally a good read. And it kind of, like I said, gets you in the right mindset. And there's all kinds of good hints and how to learn CW. Before I get there, right? Because we're going to go through general, and then we might do CW after the general book. We get through it and all that good stuff. So, all right, what else? Lots to talk about today. So, another thing that's happening this weekend is Womploda. Walmart parking lots on the air. And it's kind of like soda, and it's a lot of satellite work. Basically, you go to a Walmart parking lot and try to make QSOs on any amateur satellites you can. What is hilarious, well, not hilarious, but it's awesome, they've got the coolest, branding and stuff going on with this thing. This is the QSL card. It's Ash from the Army of Darkness with his arrow antenna and looks like an 817 or something, or some VHF, UHF strapped to his chest. So awesome. Where's the... Let's go to the... Yeah. No, that's not it. I want to show you this too, because there's all kinds of different awards. The awards were what was really awesome to me. So this is the Wikipedia, or the wiki, that's based off of the Womploda website. So check the links in the description. It's going to be there. They have one of the awards. So they've got, let's see, Early Bird Award, Express Lane Checkout Greeter, Overnight Stalker, Store Manager. The one that I am super intrigued by is MacGyver Works at Walmart Award. So let me read this to you. Achieve one QSO, just one, with an antenna built with parts purchased from the Walmart whose parking lot you are operating from. Antenna must be assembled in the parking lot and receipt picture with items and store number posted with hashtag Womplota on Twitter or whatever. You are allowed to bring a Swiss Army knife, multi-tool, or any tool that you routinely carry on your person, and also a pack of chewing gum. And an existing coax cable with connectors for connecting the MacGyver antenna to your radio. Everything else must be purchased. No modification of items that already considered an antenna is allowed, such as a CB or HDTV antenna. So cool. So I haven't looked at what the schedule looks like yet for passes, but I might try to do a quick activation just so I can get a log going on that, because I think that's super cool. So big fan of that. All right, what else we got? G-Web's completed the first leg of the Gun Show Loophole Tour. It was pretty successful. Stopped by my house, got to hang out with him, which is always fun when he comes in town. He's got a potential second leg coming up, going to the NRA show, Dragonland, which is in Colorado Springs. The Dragon Man. I have actually been there before. Very cool. Denver Antique Roadshow or Antique Show, and all kinds of cool stops that he's potentially going to make. So, and Red Dawn filming locations, which is awesome. So if you're interested in that, again, links are in the description for all this stuff that we're going through. And I think last but not least, the W6TRW Amateur Radio Club is having their swap meet tomorrow, which means they're doing their VE testing. They're testing for technicians and generals and extras. So if you are in the Southern California area and you want to get your testing out of the way, head on out there. I believe testing starts at 10 or 9 a.m. Let's see. Wait, we can do this. Swap meet. There we go. Licensing and testing. It's like I didn't know how to do this. They stop testing at 10:30. Testing hours are 10 a.m. And they stop around 10:30 for taking new applications. So I'm going to go. I'm probably going to be there tomorrow. I usually aim to get there around 9 a.m. So if people are there before they want to go take a test, they can say hi and they can bugger off and get that done. I'll probably have Ben and Edison with me, so that should be fun. Okay. All right. Let's see. What else did I want to mention? Yes, I do want to mention this too. The MFJ 4230 DMP power supply, which is right here. It's got banana plugs. It's a digital switching 30 amp power supply. This thing's really tiny. I was researching power supplies and I wanted to get something that had an Anderson power poles connection, which this does in the back. So I just wanted to give a shout out to MFJ because I really like the power supply. It's been really nice. I can power both my iComs off of it, and it's been really cool, really solid. Power supplies are kind of like one of those things. It's like it works and you don't talk about it and nobody mentions it, and it's kind of like meh, whatever. And then it's like when it fails, everybody's like, "Oh my god!" But it's kind of like an unsung hero in the ham shack because you got to have power supply, right? All right, let's catch up with the chat. How's it going, everybody? Tom says, I'm very interested in software that translates Morse code to text or voice and vice versa. They have that, I believe that's built in, let's see. It is built into the KX3 or something like that. KX2, I think, has it as well. But there are plenty of things to do it. In fact, now that we'll just do it live. Check this out. Let me see if I can make this happen. It always goes good when I just do it live, right? It feels like 25 words. Yeah. Got QSN 73 silent key WA6MOWDE K6. Yeah. So this is Morse pad. Oh, wrong camera. Wrong camera. Morse pad on my my iPhone here. Ooh, anyway, so yeah, you can totally do that. All right. Thank you, Dennis, for the 7300 comment. It is a thing of beauty. Carrie, I joined my local Aries group. Oh, that's awesome. So, why I've got a video coming out this weekend about emergency comms part 3, and I want to start reaching out to Aries and Races members that want to do an interview, so I can get some of their input on some of the stuff they do, some of the gear they use. So, I might talk to you and see if you can hook me up with somebody who knows. Not to say you don't know, but or maybe after you take some classes or you get more involved, you'll want to do the interview for me. All right, everyone, and there's great. Yes, indeed. Off topic, but what is some good software you would recommend for us fellow Mac users? WSTJX, which is the digital software for HF radio, is Mac compatible. Hamlog or Rumlog, rum like is the drink, Rumlog NG. I use that. I also use. Gosh, let me think about that one. Hold on, I'm gonna make a note and see if I can swing back around on the end of the chat. I don't want to dominate the chat with Mac software talk. I do recommend if you're on iOS, the apps that Morse Pad, all the apps that guy produces, or that girl, I don't know who the author is. I recommend all the apps that they provide. So, hey Vanessa Kitty, what's up? She's in the chat. All right. Yes. So I do have a recommendation for an SSTV app. Let me just look that up really quick so I don't forget. Sorry about that. SSTV, Slow Scan TV, is what they were doing with the ISS last week. FL Digi is a very good free app too. I use that. Where is my slow SSTV? I don't know what it is. Oh, I just wasted all that time for nothing. Sorry about that. Multiscan 3B? Yes, I think that's it. Thank you, Icebomb. Multiscan 3B. Okay. All right, we got all the good stuff out of the way. And also at the end, Tom, thank you, buddy. Where's the light? Where's my light? Where's my light? There it is. Woo! Party time. Zach, thank you, Zach, posting the Discord link. That's going to be going off after the show. I'll hop over to Discord, do some live chat. But right now, let me get things switched over. I'm going to give you the website here while I switch my camera over, because I still only have 2 cameras. I know it's kind of funny to say only 2 cameras, right? I'll let you look at the awards for. All right, here we go. Here we go. Here we go. I should take a picture of this and post it on Instagram. The crazy setup I've got going to be able to make this all fly. Thank you for bearing with me as we go through our technical challenges. That might have to be one of my next purchases is another another webcam. Did not think I would be buying more than 2 webcams, but if we're going to be looking at both, if I want to be able to switch between a radio, which of course, why would you not want to do that, and also a book or whatever we're working on, or maybe we're doing a project, like an electronics project, right? We're going to have the ability to do both. How's that look? Oh, that's kind of getting there. I think I'm going to have to turn on ye old autofocus. Ah, beautiful. It needs to be a little higher, though, still. Okay. Excellent. And I think we need some more light. Okay. That's all she's got, Captain! Robert Lackey says, got my first quad band and go to my first meeting at the local club. Still studying hard. Testing for me is the 28th of May. Going for both tech and general. Thanks for all your help, RJL. Thank you, buddy. All right, good luck. Might as well get the time to tap into this this Firestone. Got something to wet my whistle. This box for the Sukaba, which is a barley wine, which is only 12%. Only 12%. It's a barley wine, though, so. Hey, you. No, you didn't really. I just covered the news right now. Probably gonna run long today. I don't know. Got a hunch. I want to get through chapter 4. That's my goal, and I want to backtrack a bit because I need to make sure we hit the. That's a close up of my face there. If you don't mind that. Need to make sure we really understand resistors and some of the equipment here, right? So we're going to spend some more time on that right now. And I've got chaos all over my desk. Would anybody be interested in me just doing a video of my office? My crazy mad scientist office that I've got going right now? Somebody was telling me that those are always fun. I don't know, though. Okay. Okay, so backing up a bit, resistors, right? Oh, I should get beer. Resistors resist the flow of electricity, right? That should be self-evident. Get a nice little pour there. Oh, I've got bad news. Nobody's said anything, but the reason why I've got this glass is the cleaning people broke my dad's beer glass, the one that had the biru from from Thailand from the Vietnam War. They broke it. There was a set of 4. We broke one. I'm so bummed out. I'm so bummed. Okay. Yeah, fully semi-automatic bottle opener. Okay, so resistors resist the flow of electricity. That's why they've got certain ohms on them, so they resist the flow. They slow it down or add resistance. Okay? Now, depending on the temperature going through it can affect them, either being more effective or less effective. Resistors. I want to hit this up again. Okay? I like this. I was saying make a copy of this and laminate it. I still think that's a good idea. You should definitely do that if you have problems with components. And there are a lot of component diagrams and stuff like that that's in the test. So get that out of the way, get that done. Okay. Did we skip? Oh, inductors. So inductors, make sure we get the question here. We're still on resistance. This is parasitic resistance. Okay. So radio electronics use parasitic resistance of a resistor is important. Parasitic resistance means an unwanted characteristic resulted from the component's physical construction. Wire-wound power resistors are made by winding resistive wire on a ceramic form, making a small coil. Okay. This type of construction results in significant amounts of parasitic inductance that is generally unimportant at low frequencies of DC. Then the question, if such a resistor is used in a radio frequency circuit, though the inductance is often enough to disrupt the circuit's operation or affecting, be sure to use one of the non-inductive resistor types of circuits operating a radio frequency, such as carbon composition, carbon film, or metal. So it's basically saying if you've got, and this is going to be more, I guess I should make the point. A lot of this stuff you might not ever need to worry about. You might not want to build kits. You might not want to build electric circuits. I appreciate that. I do. I think that there are some questions in this book, and we're gonna see some more of them tonight that don't really need to be here. But with that said, this is the license. This is the information they want you to know, or at least be able to test on. So that's what we shall do. Is that better? I want to get a good focus there. So, okay, cool. So, yeah. Be sure to use one of the non-inductive resistor types, non-inductive inductance, for a resistor used in a radio circuit, radio frequency circuit. Okay? Inductors and inductance shows several types of common types of inductors. Double lines doesn't really explain why, and it's doing that because we should all know what inductors are from the technician class license. Right? So this is an example of inductors, an air core inductor modeled after just squiggly lines. Variable, usually if it has a slash through it, anything with a slash with an arrow means it's adjustable. And then magnetic core or iron core is represented by two horizontal or vertical bars. Okay? The inductance of an inductor, the measure of its ability to store magnetic energy, is directly proportional to the square of the number of turns and the area enclosed by each turn. Okay? Now, what's important there is if you have multiple inductors, and these are air core inductors, right? See how they're lined up together? They're creating a magnetic field. If the coils are wound, and this is the question from the test, or from the pool. If the coils are wound along a straight axis, as shown in 4.7, called solenoidal winding, the coils may be placed so that their axes are at right angles to each other to counteract the inductance, non-inductance. No, I think I'm right. Inductance. Checking in on the comments. Who do we got? Oh, K9ARV. Hey, what's up? Very cool. Okay, capacitors. So, along with resistors, capacitors are going to be the thing you're probably going to be like handling the most if you like to build kits, like I do. And capacitors basically are two plates with some kind of non or very low conductive material, either a gel or a ceramic type of material, sometimes just cardboard. And what happens is it kind of like loads up like a battery, and it evens the flow of electricity through the circuit. The best example of when capacitors and things like capacitors are used, like inductors, is when you have an AC to DC power supply, like the MFJ that I just talked about. AC is alternating current, but we don't want that for DC. We want just a steady flow, right? So what you do with a capacitor, along with other parts of the circuit, is you use that to cut out the lower half and just kind of smooth it out. So if you're just cutting and you have the tops, right, or the peaks, you need to spread that out, and the capacitors are one of the ways to do that. Anyway, we'll get into that when we talk about power supplies, which is coming up shortly in the chapter. Thing to remember, question from the pool, ceramic capacitors are also popular because of their low cost. Period. The little round disky type of capacitors, you're going to experience those a lot. They're in a lot of products that we use, a lot of kits and stuff like that. Okay? The electrolyte and the large surface area of these capacitors, meaning like this guy, this big honker right here, in comparatively small volume, large capacitors in comparatively small volumes. Electrolytic capacitors can be seen near the center of figure 4, blah, blah, blah. Let me go back up, because this is all, some of these sentences are weird. Tantalum capacitors, which are this guy? Aluminum and tantalum? Yeah, tantalum. Tantalum capacitors are similar in that a porous mass of tantalum is immersed in an electrolyte. The electrolyte and the large surface area of these capacitors create large capacitances in comparatively small volumes. That is a question from the pool. Make sure you remember that forever and ever and ever and ever. Again, still on capacitors, question from the pool. Look for the polarity markings on the capacitor to install it correctly. And I don't have a PCB I can show you, but perhaps I can show you if I see. Let me go back to the picture here. So it's kind of seen here. It's kind of seen here. Usually the capacitors that care about polarity have a black line right there, and this one has a negative logo, little slash mark. So make sure whatever PCB you're putting those into it, a lot of the PCBs are marked to match, right? So you're going to line them up appropriately, or else the circuit won't work. And in fact, you could blow out the capacitor. Hey, Elijah. Elijah's here. Got his general, but he still likes to listen to this nerdy stuff. So thanks for showing up. Okay. Components in series and parallel. We talked about this, so I'm going to kind of glaze over a little bit. I wanted to make sure we got the resistors and the capacitors. I felt I did a bad job of that, so I thought I'd go back. Key thing from this is a very helpful table to discuss parallel and series, okay? Let me turn this. What the heck? That's going to make things a lot better. Those are not all... Oop, jumped. Comment, just lost it. Where did the comment go? What was that? Anyway, somebody was commenting about electrolytic caps. Not all caps care about polarity. Only the ones that have the markings are the ones you need to worry about, which is kind of what I said. So make sure you're following that, right? You want to note what it says on it. Make sure you pay attention to that. Okay. Tom is talking to K9ARB. Very cool. All right. So, I liked this table right here. Effects on total value of adding components in series to parallel. And then it breaks it down. It says resistor, inductor, or capacitor. If you add a resistor in series, it increases. Adding in parallel, it decreases. Inductor increases. Inductor in parallel decreases. Capacitor in series decreases. Adding in parallel increases. And, okay, so you can use that. Very helpful table. That is table 43. Math. My lord. Just what I want to do while I'm drinking beer. Okay. I am not going to do the math because I don't have any... I'm not going to set up a calculator today. Also, I think these are fairly straightforward. You'll notice that every one of these is from the question pool. And they're pretty straightforward. What is the total inductance of 3 10 millihenry inductors in parallel? Okay, and it walks you through it. Right? Add them all up, divide, okay? Or distribute, okay? And literally this whole page is all on these types of algorithms. Not algorithms. Okay? All right, transformers. All right. In previous discussions on inductors, mutual inductance was introduced along with various methods of avoiding it. Mutual inductance is put to good use in transformers. Transformers transform AC power between two or more inductors sharing a common core. The inductors are called windings. Okay, there's a primary winding, a loaded winding, which is where the circuit is applied power, and then there's the secondary winding, not whining. That's what my kids did last week. Okay. Transformers can change power from one combination of AC voltage and current to another using windings with different number of turns. For example, in a step-up transformer, the primary windings carries higher current and is wound with larger diameter wire than the secondary. Okay? And to understand what that means, a significant change between primary and secondary voltage usually requires a change in the size of the wire between windings, okay? So that's where you either step it up or step it down, the power. There is... Where's the... Oh, did I miss it? Hold on. I want to go back a second. I want to make sure we cover what transformers look like in the diagram from the beginning. Yeah. Okay. So transformers, right? Ooh. Transformers. You've got two windings, right? Windings around ferrite cords, air windings, adjustable, right? So we've talked about these. Adjustable air cores, and then some kind of ferrite or some kind of material. You'll often see that with different types of components. Okay. Okay. This one's pretty straightforward. We'll talk this one really quick. What is the voltage across a 500 turn secondary winding if 120 volts AC is applied across the 2250 turn primary winding. So 500 over 2250 times 120. There you go. Which I think you go left to right. You should distribute. Anyway, use your calculator. And you can have a calculator when you're taking your test. Just remember, you're most likely not going to be able to use your phone's calculator, because the VEs, VCs, they will possibly think that you're cheating. So you don't do that. Bring a calculator. Use something else. Okay. Let's see. This is pool question. If the primary and secondary windings of a 4-to-1 step-down transformer are reversed, what happens to the secondary voltage in the equation above for primary and secondary voltage? Thus, the output voltage of the transformer would be 4 times the input voltage, right? Because it's a 4-to-1, right, step-down transformer, and you reversed it. Okay. All right. Reactance and impedance. Right? Capacitors and inductors resist the flow of AC differently than they do DC. The resistance to AC flow or current flow caused by capacitance or inductance is called reactance and is measured in ohms, like resistance. Reactance occurs because capacitors and inductors store energy. Right? So I was saying it kind of balances the flow. They get filled up with angry pixies, as AVE would say, and it gets dispersed out and let out through the rest of the circuit in a resistive way, based off of what the resistance is of said capacitor. So that's your reactance. I like how everybody's talking about Scotch in the chat. Lagavulin is one of my favorites. Lagavulin 16 year, very good. Macallan's great too. Macallan's great. Okay, the more energy is stored and the higher the voltage across the capacitor, the smaller the current that flows. Okay? Does that make sense? The more energy is stored, and the higher the voltage across the capacitor, the smaller the current that flows. Oh, I realize what's going on. This thing is, the arm is slowly dipping down. Sorry about that. Where is the weak point? Okay. Okay. Inductive reactance, inductors. Sorry, this is just reading out the book. I'm starting to think maybe we should do this differently. Maybe we should do more practice tests. We might do that later. What time is it? 7:33? We got some time. Let's see if we can knock out some more of this. Inductors also resist AC current, but in a complementary way. If a DC voltage is applied to an inductor with no energy stored, the resulting current creates a changing magnetic field that opposes the incoming current. Initially, the current flow in the inductor is very small, but generally builds up, storing more and more energy until opposition to the current disappears and the inductor is fully charged with magnetic energy. Okay, so it's kind of a large ramp up until it hits maximum. I'm waiting for my antenna tuner to show up. Oh, reactance and impedance, my favorite. Yeah, it's a real page turner. Make sure I get some more beer right now. Speaking of beer, it's got a sweet taste for a barley wine, which a lot of them do, but it's not too saccharine syrupy. Impedance is a general term for the opposition to current flow in an AC circuit caused by resistance, reactance, or any combination of the two. Okay? Boom. Commit that to memory. That's an easy one to remember. Okay? Impedance is symbolized by the letter Z and is also measured in ohms, just like resistance and reactance. Again, there's another question. Commit that to memory. Like resistance and impedance, it's a ratio of voltage to current. For example, figure 4.31. This is this one with a black box. I like when they use black boxes. The impedance of whatever is the black box is computed as the implied voltage of 250 volts AC divided by the measured current of 2 amps. Okay? The result is 120 the result is 125 250 V AC divided by the measured current of 2A. Okay. Resonance is a keyboard. You're going to have to go for a while. Sorry, bud. Resonance, in its broadest definition, resonance is the condition in which there is a match between the frequency at which a circuit or antenna naturally responds and the frequency of an applied signal. Resonance in a circuit or antenna occurs when the capacitive and inductive reactances present are equal. Okay, that is the point of an antenna tuner, right? We're trying to match the circuits. We're trying to match the capacitive and inductive reactances. We're trying to make them the same, right? So we use 50 ohm coax to an antenna that has whatever its characteristics are, and we're trying to match that to the output of the radio. Whoa! Sketch Coyote, man, scared me. Sketch Coyote, thank you, buddy. $20. Thank you so much. Long-time watcher, first-time screen watcher. Use your vids to get licensed, so now I'm using these vids to get general. Just join the Discord. So look forward to being in the community. Local to SoCal, right on, man. Make sure you're also on the Ham Radio Crash Course on Facebook. Because I, at work... What the hell was that? At work, nobody's here. I just heard like a bang, so... You got a handgun close at hand. We're all right. I can't use Discord at work because my cell phone really doesn't get signal, and they won't let me load Discord on my company computer, nor would I. So Facebook is the more often thing. I hit that at lunch, whatever. All right. Hosh Nasi, Jerry and Tony make great YouTube videos. I always learn something new. Oh, yes. All of them, I guess including me. Thank you, Tom. Okay, where were we? Okay, so resonance. That is the point of matching an antenna. And in fact, I think, if we flip the page here, impedance matching. Here's a whole thing on impedance matching, okay? The internal impedance of a source, so again, it like a light bulb, not exactly like a light bulb, but your antenna is the load. It is what you're applying the power to. Right, it is a part of the circuit, and it's resonating, shaking violently, and shipping that RF all over the place. Shipping it. Okay, the internal impedance of a source limits its ability to deliver power. For example, a hearing aid battery and a D-cell, right, comparatively large battery versus small battery, may supply 1.5 volts, but the internal impedance of the hearing aid battery is much higher, limiting its supply to small circuits. The D-cell's lower internal impedance enables it to supply high currents, meaning you would need a whole bunch of like hearing aid batteries if you wanted to make like a taser or stun gun or whatever, but you would need less D-cell batteries if you wanted to use that because you could apply more current. Okay? Knowing the impedance of a current is particularly important when the goal is to deliver the maximum power from a power source, such as a transmitter, to a load, such as an antenna. Okay, and here's where this gets all this stuff. All of this page 419 is a very good page, because particularly when you get to HF radio, which is what we're talking about, which is what we're doing, you're gonna spend a lot of time futzing with antennas, like I am, like Jerry does. His speaker cable dipole, that's futzing around. It's cutting it so that it's perfectly resonant on the frequencies that you want to use it. That is its impedance matching. You're matching the impedance of the load to the rest of the circuit. Okay? There you go. According to the maximum power transfer theorem, maximum power transfer occurs when the sources and loads output impedances are equal and purely resistive, meaning no reactance. Amateur transmitting equipment is designed so that the source impedance at the output, or output impedance, is 50 ohms. Hence why we use coax, right? 50 ohm coax. Use 50 ohm coax. Yeah, good point. Tom says math is about 10% of the questions. I'm doing this to be as accurate as possible and just going through the book. We will start taking practice tests. you will find that you're not going to do that much math. And you could probably screw up on some of the math questions and still totally pass the test. So, G-Man00197 Gaming, he's got to head out early. So, understand, dude, family's important. Take it easy. Sketch Coyote, happy to be here. Yes. Oh, very cool. He's been a ham for a while. 2 fails. Oh, It's Swift says 2 fails at Wimplota. Some really lousy OP on an AO92 tonight. That sucks. That sucks. Yeah, that'll ruin your day because there's such a limited time for a contact. Excuse me. Okay. Most coaxial cables have a 50 ohm characteristic impedance. Most antennas are designed to have a feed point impedance of 50 ohms, but they rarely present that impedance over an entire amateur band. So who's seen my videos or just any videos of an antenna tuner that has a graphical display and it's kind of like a bell curve, right? You're possibly right centered, right where the lowest SWR is for that antenna. The lowest, right? That's a match. It's closer to a match. But as you start to shift the frequencies up and down the band, you're going to have the SWR creep up because no antenna is perfectly matched at the entire band. That's let me use the dipole. The dipole characteristically, when it's cut to a length, right, is cut to a length given a certain frequency, right? And then as you get out of that frequency, as you step over to left or right of that frequency, your SWR is going to go up because you've fallen out of some of the impedance match. Okay? I love lasers. Statistically, you'd only get 2 to 3 math questions on a general exam. I think I only had 1 when I took mine. There you go. So keep that in mind. I think regardless of the math stuff, this impedance matching is the best thing in this chapter, or most important thing. So most impedance matching circuits are LC circuits made of inductors and capacitors. So to be honest, you can understand the whole concept of impedance matching and never really care anything about an LC circuit. You don't need to know what an LC circuit. Yeah. Oh, you just nailed it. KG5UBB, he just said, wait, is this how antenna tuners work? Like L network tuners? Yeah, LC circuits. There you go. Yeah, so you understand, I've said this before, tuners don't make the radio, they don't, what's the right way I'm saying this? They make it so you're not damaging the radio. You're not effectively necessarily pushing all the power out of that radio into the antenna if it's a poor match, because the tuner's kind of like dealing with some of it. It's making it so that the whole circuit is matched, which means you're burning through some of that power. Okay? Another popular method of performing impedance matching was introduced in the section on transformers. Why would they? Okay. Impedance matching can also be performed by special links and connections of transmission line. Yes. So if you want to change the frequency match, you just lengthen or, lower how long the legs are if we're talking about a dipole, right? You got 2 legs to a dipole. Just reduce it in length, right? Reducing it in length increases is for increasing the SW. No, I'm sorry. The higher the frequency, the shorter the antenna. The longer the lower the frequency, the longer the antenna. So keep that in mind. If you want to make your antenna resonant on 7.033 40 meters, which I'm on right now, that's going to be shorter than 7.233. Okay, I'm sorry. That's going to be longer. Yeah, longer. Yeah, listen to what I say, not what I say. All right, active components in circuits, semiconductors. Radios today exist because of semiconductors. Computers exist today because of semiconductors. So it's important to at least kind of understand what they do. So semiconductors are materials that conduct electricity better than an insulator, but not as well as metal. Silicon and germanium are examples of semiconductors used in radio electronics. The electrical properties of semiconductors can be controlled by the addition of small amounts of other materials, such as indium and phosphorus. These impurities are called dopants, and adding them to the base material is called doping. If the impurity's presence creates more electrons to conduct electricity, the result is N-type material. Otherwise, the impurity creates P-type material. All semiconductors are created from combinations of N-type and P-type material, where the two types of material are in contact in a P-N junction. Okay? Great. Diodes and rectifiers. A semiconductor junction diode uses a P-N junction to block the current flow. See right here? P-N junction. This is right here. Okay? Negative, positive electrons. P-type material, N-type material, junction in the middle, anode, cathode, positive, negative, positive, negative. Okay? P-N junction consists of P-type and N-type material. The junction is formed at the boundary between the layers of the material. Wire leads are attached to each layer. Current flows when positive voltage is applied from the P-type to the N-type, called forward bias, forcing electrons across the junction. Voltage applied in the reverse direction from N to P-type are called reverse bias, pulls electrons away from the junction so that no current flows. The voltage required to force electrons across the junction is the diode's forward voltage. Where is it? There we go. Forward voltage and threshold voltage, as abbreviated by VF. For silicon diodes, VF is approximately 0.7 V, and germanium is 0.3. Okay, why would you need to know that? I mean, you possibly would, but I do admit freely that there are some questions that you might not need. You might not need. Okay. We're going to start moving here because back-to-back layers, bipolar and field effect transistors. Nope. I'm going to skip that. Some of these stuff is just read it and learn it and then remember it. I can't make you remember it, and my reading it's probably not going to help you that much. But some of this stuff is important to break it down and talk about it a bit. Okay, the metal oxide semiconductor, FET, or MOSFET, and related device, the insulated gate FET, or IGET, have an insulated layer of oxide between the gate and the rest of the transistor. There you go. That's easy to remember, right? And again, I'm highlighting a lot of these because these are from the question pool. What's nice about this book, it tells you exactly where that question came from, what section of the question pool, so that you can keep. I found that as you use the app, what I do is I take the practice test, and where I really fail, that's the section I focus on, and I use the book, particularly the questions here. I find that question in the question pool where it's talked about, and I read through that section. So that's a big tip there if you're doing this kind of stuff, is take practice tests, go to where you're the weakest, go to that section in the book, and just kind of plow through it over and over again. Highlight, make notes, do the whole thing. Both JFETs and MOSFETs are very sensitive. Where's a MOSFET? There's a MOSFET. That's a MOSFET. Okay. With small amounts of voltage, able to control the source drain current. High amplification transistors. Okay. Similarly, the input signal can reduce output current to 0. The condition of cutoff, these two states make an excellent representation of digital on-off signals in logic circuits. So you're literally creating like a binary switch with some of the stuff, the way these are used. Okay. Transistors come in many types of packages. Okay, great. But the point here is be cautious when installing or replacing high-power transistors to avoid short circuits. Ground the device, whatever it is, as much as you can. If you're going to work on something that has had a power applied to it, a load, not a load, yeah, a load. Anyway, if it's plugged in and was operating, particularly a radio, old CRT monitors particularly, try to ground that thing so that you can let the power out, because you can. Okay, here's a section that every one of us will have to deal with in the future. I'm just kidding. Vacuum tubes. What can I say? Vacuum tubes in ham radio are cool. Totally, you can live your entire life and never have to mess with one. The most likely place where you'd ever have to mess with vacuum tubes is on an amplifier, maybe. Tube amplifiers still exist. Tubes are technically still manufactured. Some are anyway. And they can be good to know about. Good to operate with, maybe. Maybe you find a nice old Drake radio. By the way, guys, if at any time you're out at a swap meet or anything like that, and you happen upon a really cool radio, take a picture of it and put it on the Ham Radio Crash Course if you're curious if you should buy it or not. I'll try and see it. I know there'll be other people who will comment on it. Some of the boat anchors can be really nice radios. Any of the Drakes, if you find a nice Drake set with a transmitter, receiver, if it's that type, if it's probably before transceivers, with a power or with an amplifier, great. Cool radios. You may only be able to do AM with it, but regardless, CW for sure. Very cool. If you've got the space. They do take up a lot of space. Okay, vacuum tubes. Okay. The vacuum tube, the oldest device capable of amplification, still makes a valuable contribution to high power. Oh, see? Oh, I didn't even read that part. Yeah. Carrie says tube amplifiers are still very much in use. Absolutely. Yep. In addition to amplifiers, many amateurs enjoy using antique tube gear, as I just mentioned, just as audiophiles do. It's also worth noting that on HF, there is still very much a live section of people who just work amplitude modulation. Kind of has a warmer sound. It's kind of different. We may poke around later, depending on if we have time. Probably not going to have time. Not today. I'll put that on a list of things to do. Show you around what it looks like. Go and just, dialing around the bands and hearing what things sound like. Particularly depending on the day, right? Noise levels and all that stuff. Anyway, vacuum tubes have three basic parts: a source of electrons, an electrode to collect the electrons, and intervening electrodes that control the electrons' travel from source to collector. Each electrode of the tube is called an element. You've got parts, some of the terminology. Filament or heater heats the cathode, causing it to emit electrons. Cathode, the source of the electrons. Control grid, the grid closest to the cathode used to regulate electron travel between the cathode and the plate. Screen grid, an electrode that reduces the grid-to-plate capacitance that diminishes the tube's ability to amplify at high frequencies. Suppressor and the plate. The electrode that collects the electrons, called plate current. All amplifying tubes have at least three electrodes: a cathode, a grid, and a plate. Heated to a high temperature by a heater or filament, the cathode emits electrons into the vacuum of the tube. The plate is replaced at a positive voltage. The plate is placed at a positive voltage. With respect, can you see that? No, sorry. You know what? Let's just look at this. Heater, cathode, screen, control, plate. There you go. That's a vacuum tube. Yeah, Casablanca. The bands are not bad. Fair is actually pretty okay considering our sun cycle. These are logic functions. We're going to skip logic functions. Okay. RF integrated circuits. Okay, ICs are the thing that looks like little millipedes, right? A little stick or bar with the vertical legs coming out of it. Those are ICs. RFICs are specific. Was there an actual comment on ICs? Did I skip a large portion of this book? I just did, didn't I? Yeah, did. Oh, let me make this note real quick. Here's a question from the pool. Compared to different types of semiconductors, the tube is most like the field effect transistor. Just remember it. That's one of those things you're probably never going to experience. Okay. No offense to ARRL, but some of this stuff is getting a little out of date. But if you like tubes, it's cool, Analog and digital integrated circuits. If one transistor is good, more must be better. The process that makes transistors into thin wafers of silicon can just as easily create many diodes, transistors, resistors, capacitors, and even tiny spiral inductors and connect them with wires made of thin, plated on metal. The result is the IC, also known as a chip. The most common type of integrated circuits are analog or linear, and digital or logic. Okay, so that's an IC. This is the schematic for an IC, right? A chip, right? And it's pinned out 1 through 4, 5 through 8. Okay, chips. Prevalent in all of your kits nowadays. Figure 422 shows the schematic symbol and connection diagram for two of the most common analog ICs, the operation amplifier and the linear voltage regulator. Questions from the pool. Digital ICs operate with discrete values of voltage and current representing the binary number system values 0 and 1. Digital electronic circuits operate with only two stable states of operation, on and off, representing binary values. So it's basically the basis of like computers at this point is what we're talking about. You gotta have chips. That's eventually gonna get you to a computer. Yeah, Robert, you're good to go. Just go take the test. You don't need to worry about. You could skip this chapter completely, probably. The most popular logic family in use today is the Complementary Metal-Oxide-Semiconductor, which is your CMOS chip on your computer, right? CMOS. Complementary Metal-Oxide-Semiconductor. Yeah. Al, my uncle was an engineer back in the day and aced all 3 tests in one sitting. Yes, indeed. I believe it. I wasn't a double E, so a lot of the circuitry stuff is kind of foreign to me, and the math for calculating a lot of stuff is foreign to me. The components all make sense. I get what they do. I like building kits, but I'm like, I can't really build a circuit. At least I can't right now. RF integrated circuits, a MMIC, or MMIC, monolithic microwave integrated circuit, is a special type of RF IC that works through microwave frequencies. Just remember it. Microprocessors and related components, where digital control and computing functions were once performed by complex circuits of many discrete ICs. Today, these functions are performed by miniature computers called microprocessors. Okay, this is where we're starting to talk about DSPs, digital signal processing. This is kind of pre-SDR, like the 7300, which is 100% SDR. The Zyju or the Zygu X5105, my other radio, my QRP radio, my SOTA radio, has DSP. Okay. When digital control and computing functions were once performed by complex circuits of many discrete ICs, today's functions are performed by miniature computers called microcontrollers. I just read that contain thousands of gates in a single IC, often called a chip. Microcontrollers are a special type of microprocessor with extra interfaces to external signal and control circuits. 2 questions in 1. Okay. Oh, thank you, Robert. Appreciate the comment. Okay. Memory and interfaces are kind of, let's hit the questions really quick and hit the preface of it. But it's memory, man. Machine language program must be stored in some kind of memory devices so that the microprocessor can read the instructions. There are several kinds of memory. Volatile memory loses its data it stores when power is removed. Non-volatile memory stores all data permanently, even if the power is removed. So non-volatile memory is an SD card or double EEPROM if you guys work on single board computers or anything along those lines. A RAM chip, random access memory, a chip that goes into your motherboard, that is volatile memory unless it has a power source backup like it's one of those RAM hard drives. Okay. Non-volatile memory loses data permanently even if the power is removed. Question: random access memory can be read from or written to in any order. Read-only memory, ROM, stores data permanently and cannot be changed. In general, yes. Read-only memory cannot be changed. There are some read-only memories that can be reflashed. Double EEPROM being one of them. Okay. Stores permanently can be changed. Okay, good. That's those questions. Right, here's another question. Computers sold today use USB interface, although older computers still do RS-232 serial, and USB serial interfaces in the ham shack are used to connect computers to transceivers TNCs, and multi-mode communication processors, as well as to accessories such as antenna switches and rotors. Great. Computers. Some of these questions, man. See, that's an easy question. That's a real easy question. You should be able to, like, have no problem with that. Right? I think so. Common indicators are the incandescent light bulb, light emitting LED, a display, no. Okay. An LED is a diode made from a special type of semiconductor material that emit light when the PN junction is forward biased. So what does that mean? That means you have to put an LED in the proper hole. One leg is longer, and that is the positive leg. Must be on the positive side of the circuit. Make sure you remember that, or the LED will not work. LCDs, screens again, require ambient or backlighting, a light source. This is so weird, since the liquid crystal display does not generate light on its own. Kind of a 90s question, right? Doesn't that feel like the 90s? An LCD requires a backlight. Remember when the Game Boys didn't have the lights behind them? I remember that. That's what that feels like to me. I don't know. Rectifiers and power supplies. All right. Almost every piece of amateur equipment requires power. Yes. I can't think of any that doesn't require power, unless it's an antenna. Electronic equipment requires DC to operate, so a power supply is required to run equipment from household AC power. Almost everything runs on DC, right? So we're talking, you got to have a power supply. Power supplies take in AC, cut it in half, basically, space it out or soften it. And there you go. Rectifier circuits. A half-wave rectifier shown in 4.24a permits current flow during one half of the input AC waveform, 180 degrees from the transformer. Okay? That creates a series of pulses of current in the load at the same frequency as the input voltage. Boom, 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 boom. Okay? This is an equal duration between pulses with no current flows. The rectifier's output waveform's average voltage from 0.5 times the transformer's winding. There's also one. Okay, cutting it in half. So you start it out here. You run it through a transformer. Anode, output. Boom, boom, boom. You just cut the bottom half. Cut the bottom half off. Sketch is taken off. See ya, man. Yeah, let me catch up on Hammer Crash Course, right? Send a post there. Is it LW? Yeah, I think it's LW. That font for L is not good. Try to explain to one of the Best Buy geeks why you need a USB serial interface. The look on their face, priceless. I love Lasers is saying, I'm waiting for this book to say, the internet is a series of tubes. Yeah. Where's G-Webs? G-Webs will say it. He'll say it right now. Okay. So this one, okay, let's compare and contrast these because this is an interesting point. So you've got a diode, anode, cathode, and then this goes to a filter, and here's your load, whatever that may be. And your output is this kind of dirty power. It's boom, 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 boom. It's like a stator motor on a generator, not an inverting generator like the Honda or the Yamaha. So you're getting this dirty power. Boom, 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 boom. Okay? What happens if you run that back through in your secondary winding? Well, then you get a faster boom, 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 boom. Electro boom joke. Full bridge rectifier. Insert electro boom joke. Yep. Electro boom. Is that a That's a thing, but was that also a YouTube channel? I don't remember. The output from full wave rectifiers is a series of pulses at twice the frequency of the input voltage. Yay! What's another one? The advantage of full wave rectifiers is that output is produced during the entire 360 degree of the AC cycle. Yes, that is the importance, right? That is the importance. Okay. This full wave center tapped, what is this? Full wave center tapped, rectifiers, half wave, and full wave. Yeah, That's what I thought. I went to a class at work for ESD training, electrostatic discharge training, and they used his video where he had that ESD gun and he kept shocking the crap out of himself. So funny. Dude is great. Electro Boom's hilarious. What was he trying to make? He was trying to make a Jacob's ladder and he kept just burning all the wire up. It's so funny. The peak inverse voltage applied to the diode in a half-wave rectifier, remember, boom, 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 is twice the supply's peak output voltage. In a full-wave bridge rectifier circuit, each rectifier diode only has to withstand the supply's peak output voltage. My dog's crying. Crap. Hold on. I'll be right back. I don't think ads ever work on this thing. I'm going to play a quick thing if I can. All right. Hopefully that's going to play. I don't know if it's playing an ad right now, but I'll be back in a second. Sorry. I heard dogs like to drink water. Who knew? Okay. Oh, James. James asked a question, bit of an aside question. I'll be using a new radio on my bike with an output of 25 watts. I'm planning on using a 12 volt, 12 amp hour battery. The radio is a 2 meter, 70 centimeter rig. Would this be enough power for a full day of use? So, James, it depends. Do you mean full day of use if you're holding the mic down and riding down the road for 8 hours? No, not at all. Yeah, of course, more listening. I don't. Yeah, it would be fine. It's most likely fine. And remember, as a good operator, the best thing to do is start your call or whatever it is you want to do with 25 watts of power, and then dial it back. The lower that you can make your transmission, the longer the battery's going to last. Yeah. How are you going to charge it? Keep it charged up. Anyway, I'll keep going, and I'll read the chat as you go. Filtering circuits. So, a rectifier's output pulses of DC current are unsuitable for direct use by electronic circuits. The pulses must be smoothed out so the output is relatively steady voltage. The smoothing is performed by a filter network consisting of capacitors or capacitors and inductors. We talked about this earlier, right? This is exactly what we're saying. More listening. What kind of... Not necessarily. That's not a lot of weight on a bike. In fact, quick shout out. These guys are pretty cool. I've got a Dakota lithium battery here. They compare themselves to the Bio-Eno and are made in America. Where is the... it's a 12 volt, 10 amp hour. This thing is so light, man. In comparison to a lead acid, this is no problem. This would be awesome. In fact, I'm going to use this on field day. This thing's very cool. The video the emergency comms video that's coming out this weekend, Bio-Eno battery. Yeah. Oh, is it Bio-Eno? Is that what you're trying to spell? Same deal. This is the same thing. The only advantage of this guy, which I understand, is these will charge off solar charge controllers, and they don't require a special charger or a special hookup like the Bio-Enos do. And I have Bio-Enos. I like them too. They're just a little bit more fidgety. You've got to use the connector and the charger that come with it to make sure you're charging all these cells evenly. I'm not a big fan of that. Anyway, filter circuits, you got to smooth out the power. So you're going boom, 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 boom. Oh, hey, thank you, Franklin. Thank you for the hard work. Hosh, thank you for that. Appreciate it. Power supply safety. It's full of electricity, yo! That's the safety. There you go. Just like anything else. By the way, if you build a power supply, who was building the power supply? Was it Jeremy in the ham radio crash course? You could get hit. Be careful out there. Safety is important in power supply design. because of the connections to the AC line power and because a lot of energy is supplied by and stored in the supply. Fuses in the primary are used to protect against the hazard of excessive current loads or short circuits. If you are working on a power supply, be sure to wait long enough for the bleeder resistors to do their work after turning the power off. Yes, please do that. Don't be in a rush. And if you're ever playing around with an arcade cabinet, trying to fix an arcade cabinet, keep that in mind. Those CRTs are loaded with power. Not a lot of bleeder filters in those bad boys. Okay, here we go. Batteries and chargers. This is where it's going to get fun. Battery power operation is important. Wow, we're past an hour. Awesome. We're going to go. We're going to keep going. I want to get through this chapter. We're getting through the chapter. Battery-powered operation is important to amateurs. Indeed, everyday use of handhelds and portable radios requires dependable, high-capacity batteries that can be easily recharged. Public service and portable operations depend on battery power. Okay, here's my problem. For emergency operation, disposable batteries are preferred because battery chargers may not function if AC power is unavailable. No. I mean, yes, but no. If you have disposables, use disposables. There's no reason you can't have a generator that you run your charger off of. Or have a solar panel. Solar panels are cheap now. Hey, what's up, Biker Bob? Solar panels are real cheap. This battery, great off solar panels, good to go. Right? There's no reason you have to go fully disposable. It's nice. It's nice to have the option of running on disposables. No question. But, yeah, don't play with Variacs. Indeed. So this is kind of old, this section here, but we're gonna talk about it a little bit. Secondary batteries can recharge and be reused many times. Yeah, rechargeables, great. An example of secondary batteries, and they're referring to rechargeables as secondary batteries. Nickel cadmium, nickel metal hydride, lithium ion, and lead acid. Okay? Fine. Lead acid storage batteries can produce useful power until their output voltage drops to approximately 10.5 volts, after which the voltage will fall quickly and the battery should be recharged. Discharging these batteries past their minimum voltage will reduce the life of the battery. That's an easy question to remember and is generally true. Some types of batteries, such as NiCads, are especially designed to have a low internal resistance to supply high discharge currents. Remember it. That's just remember it. Charging batteries. First, never attempt to recharge a primary battery such as a carbon, zinc, or nickel or silver nickel, meaning don't recharge a non-rechargeable battery. That is a question in the general test. Shocking. Okay, alternative power. What is most often meant by solar is really photovoltaic conversion of sunlight directly to electricity. Again, common sense. The forward voltage created as the electron crosses the junction is approximately 0.5 volts and can be measured as an open circuit voltage of a solar cell. That's how solar cells work. That's just a question to remember. Lock it in your head. Energy storage. A substantial energy storage system when the sun is down. Okay. Systems that create energy from wind and solar power require one more component that adds to the cost of using them. A substantial energy storage system. Sure. Or you just don't run it in the dark. Okay, I'm talking connectors now. Okay? Connectors don't need all this text behind it. Just, these are connectors, okay? I use these the most. Power poles. This is what that power supply that I'm using runs off of. They're great. Molded nylon, Molex, fine. Banana jacks, banana plugs, binding posts. That's on the current power supply. All fine. They're connectors. They're ways of joining things together. So, case in point, I have my Bio-NO battery with an Anderson power pole connector. This power pole connector goes to two spade connectors, positive and negative, which connect to these posts. So I can use this little dongle adapter on any radio that I have that needs a power supply connector. And I could either have it connect to the back of the MFJ power supply, or I can connect it to the battery. It's nice to have a couple of those on hand. All right. Quick disconnects, right? If you wanted to connect multiple feed lines together, multiple power. I use ring and forks a lot on connecting antennas to binding posts. I like these guys a lot. I will make a note here. Step 1, strip the end of the wire. Got it. Insert wire into terminal. Crimp the terminal to the wire. I go a step further and remove this plastic shield, put some heat shrink over here, pull it off to the side, and then solder it on. Crimp it's fine. Absolutely crimp it up. But I always solder my connectors usually. The only connectors I don't solder are connections to ground posts. Because if you get hit by lightning, for example, the lightning will instantly liquefy the solder and spray it all over the room. So don't do that. CAT cables are used, or mini DIN cables are used for CAT control, computer automated terminal tuning. Anyway, it's how your computer controls your radio. That adapter, I currently need to go find one of those so that I can hook my little mini jack key up into the back of my 7300, because the 7300 wants these big old beefy connectors. Okay. Let's cover the questions really quick. Phono plugs and jacks, sometimes called RCA connectors, since they were first used on RCA brand equipment, are used for audio, video, and other low-level RF signals. They are also widely used to control signal. They are also widely used for control signals. Cool. DIN stands for Deutsches Institut für Normung, the German standard organization. DIN and mini DIN connectors are keyed and have up to 8 pins. Keying is nice. Keying is real nice, because that means it only goes in one way. That's what we're talking about. I like keyed connectors. A couple antenna connectors that you're most often going to see. B and C, right here, female and male. UHF, phono, and where's SMA? These little itty-bitty nubbins off the side there are both SMA. Okay. UHF connectors are typically used up to 150 megahertz and can handle a legal limit transfer power at HF. Meaning full power, the connector can handle it. You're good to go. No problem with the amplification. Type N connectors can be used to 10 gigahertz. Type N connectors are those guys. They're expensive. Okay. Handheld transceivers often use SMA connectors for attaching antennas. There's my comment, go BNC. Go buy an adapter with a grommet or bushing that kind of strengthens the connection around the SMA, and go get a BNC connector. SMA connectors, I think, are only supposed to be good for 100, 200 something connects and disconnects. So if you like to change antennas, if you're never going to change antennas, don't worry about it. SMAs look kind of sleek. But BNCs look really nice, and being able to quick is great. Okay. This is it's kind of a dumb one. I'm not sure which side this question's on. I don't know if it's the USB side or up here, but for example, D-type 9-pin connectors are often referred to as DB9 or DE9 and are used for COM ports on PCs. Yay. Okay. This is the stuff I like. Testing equipment. Basic test equipment. So first and foremost, for most of you guys that are coming out of technician land, you didn't need a lot of equipment. Some of you probably maybe had an SWR power meter that kind of went in between two transmission lines or two lines of coax to your load, your antenna. Yeah, it's probably helpful if you're doing a mobile installation for a car or whatnot, but for HF, you're going to need a lot more. Need is a subjective word. You will want this. You will want these. Volt-ohm meters, VOMs. Garden variety meter can be purchased for $20 or less. Harbor Freight has them sometimes free. In no way should you use a Harbor Freight as your go-to default primary voltometer, but it'll work. You should get a better one. But with that said, that will work for the time being. You can measure voltage, current, and resistance, act as a continuity checker, test diodes and transistors. For a few more dollars, you can add frequency counting, component value, capacitance, inductance measurement, and a data interface to your PC to record readings. There are two types of bombs, analog and digital. Most people will experience digital only, and that's probably what you'll end up. However, in fact, experienced hams prefer analog meters for finding a peak or minimum reading, such as when adjusting a tuned circuit, since it's easier to just watch the meter needle move than a numeric display, meaning move to the highest point. That's what they're looking for. They want to see the highest point. Horror fraud. Harbor Freight. Harbor Freight. Whatever. I like Harbor Freight for cheap stuff. Digital multimeters also offer significantly greater precision. Way higher precision in digital. When measuring voltage, the meter should have a high input impedance so that it places a minimum load on the circuit being measured. Just remember it. Oh my gosh, I saw the end. We're almost there, guys. All right. Scopes are very useful. This enables the technician to observe complex, fast-changing waveforms that are beyond the abilities of meters to measure. So something like that, right? External signals from circuits under test are connected to the scope through horizontal and vertical channel amplifiers, right? Here's your vertical channel. The gain of the amplifier is variable to adjust the sensitivity of the oscilloscope's display. If you have never used a scope before, I don't have an oscilloscope. You got me. I don't have one. And there's tons of tube oscilloscopes are at the swap meet like every month. I haven't popped on one yet. I haven't needed it. That's one thing. It's like when you need it, you need it. I haven't needed it, so I'm not going to get it for right now. The gain of the amplifiers is variable, so just remember this. An internal time base usually sweeps the electron beam along the horizontal axis at a highly stable calibrated rate so that the scope can make accurate measurements of time and frequency. They're great. If you need it, you need it. In an amateur station, a monitoring oscilloscope is very useful for monitoring transmitted signals by connecting the attenuated RF output of the transmitter to the vertical channel of the oscilloscope. That's great. Do that. Being able to monitor the transmitter output waveform in real time is a great assistance in adjusting keying waveforms, microphone gain, and speech processing. No question. Daniel asked me, what kind of hat is this? This is a bicycle hat. It is a bicycle hat with some funny, you're not going to see this because of the green screen, but this is the ARRL logo, and this is a NASA logo that has WTF instead of NASA written on it. Scopes are a must, says Robert. Is it Lackey? It's Lackey, right? It's not Lakey. Lackey. With that said, get it when you get it. To me, the most important thing is impedance and resonance measurements. So an antenna analyzer. This one being one of the most popular or somewhere in the family. They've made a bunch of different models of it. The MFJ antenna analyzer is one of the most popular thing you'll ever see in antenna whatevers. This is the one I use. This is awesome. The Rig Expert AA170. Oh man, so light, so nice. So nice. Very nice. Anyway, MFJ is great too. Okay. What it does, the analyzer contains a CW signal generator, a frequency counter, an SWR bridge, and an impedance meter. Different models of analyzers can display both resistive and reactance values of antenna impedance, as well as the precise frequency at which the measurements is being made. By connecting the analyzer directly to the antenna feed line, SWR can be checked without having to transmit a signal at high power. Awesome. Awesome. I love these things. I love them. Tell somebody asking me to tell them how to triangulate. Yeah, I can tell you how to triangulate. We should do that. We should make a whole video on that. It can't be a live stream because obviously, I'm gonna be disconnected from my computer if I'm doing a DFing. The analyzer is also capable of measuring feed line velocity factor, electrical length, characteristic impedance of parameters. The exact procedures for all measurements are explained. Okay, yeah, sure. Point of caution, however. Because the analyzers use small signals to make adjustments, its accuracy can be affected by strong signals from nearby transmitters. Absolutely. Absolutely. Sat Fan. Hey, got a question. Is ham radio is still a thing with the booming of... Absolutely. If anything, it's more popular than ever with the booming of the internet because we've just brought the internet into ham radio. We've just adopted it for our twisted use cases of the internet when we need it. Like now we cross-link repeaters. We can have a repeater up on a mountain that I can talk to 50 miles away from it. That's got an internet jack on the side of it. You know, an internet jack to the series of tubes. And then it can connect to repeaters all over the world. We've got a repeater network that can connect to Japan, up and down California coast. Amazing. And if the power goes out and the internet goes away, we can do internet, we can do Wi-Fi networks with our radios. There you go. Field strength and RF power meters are also really nice. So with these, you can take measurements as to how your antenna is modeled, right? While you're transmitting, you can walk around with a field strength meter or turn the antenna, and you can see the change, and you can model that as a sphere or a circle around a vertical space. Field strength meter. Oh, we did it. Jesus. It is often used to compare relative levels of RF output during antenna and transmitter adjustments. Okay, meaning you can use a field strength meter to rotate around an antenna to determine where it's most effective in its resonance. Because some antennas are not just vertical, omnidirectional. Conversely, a meter can be carried to different locations to determine the radiation pattern of a fixed antenna, such as a wire beam or array. Boom. Awesome. Standing wave ratio can be calculated from forward and reflected power measurements made by using a directional watt meter. There you go. Remember it. Okay, man. That was a struggle. Radio signals and equipment is chapter 5. Let's see. What will we learn? Basic signal concepts, oscillators, mixers, multipliers, modulators, transmitters, amplifiers, fundamentals, receiver fundamentals, installing an HS station. Whew! I think I'm going to do that one next week, most likely. Let's leaf through here. Oh, yeah. This is what I'm talking about. Oh, yeah. How big is this one? Oh, good. Digital modes. Look at that. Is that a KX? That is... What is that? Yeah, it's KX3. Really? Huh. All right. Whew. Whew. Okay. Why don't you guys start asking some questions while I move things around a little bit? Because I think I'm going to end here shortly. But I will take questions because I know we had some questions that might not have been answered in the chat. If they were, thanks for whomever did the answering. Appreciate that. I'm going to switch back here so you guys can read some of the rules of Umplota. Well, Jesus. Pay no attention to what's behind the green screen. What am I doing? Get back to that sweet, sweet, sweet 7300. Yeah, I think another webcam might be in my future. This is redonk. Jeez. even if it's not perfect. That's pretty good. Who made the lithium-ion battery I held up? This is a Dakota lithium battery. DakotaLithiumBattery.com. It is a 12-volt, 10-amp-hour battery. Awesome. Very impressed by the weight of this thing. This thing, maybe 2 pounds. Maybe 3 pounds. Great battery. Carrie says, I'm having trouble hanging up my roll-up J-pole. Would hanging it above a dryer mess it up too bad? No. What's the problem that you're having? Do you have a tree in your area? If you have a tree, throw a cord, like paracord. Throw a paracord with a rock over a tree limb and just hoist it up. When is your next soda activation? Hopefully next week or the following week. For sure, Tom asks. Daniel says soda will be cool to use as well as sending text messages. Soda is just the summits on the air. You might be talking about QRP, as in low power radios that are highly portable. Franklin Lewis asks, are you planning to do an extra class after the general study guide is done? So I don't even have the practice test for the extra. I don't think so. Not right after. It's going to be a while. Because that's going to be way more math. And frankly, I don't want to do the math. I don't want to do the math. I don't really like doing math. I really don't. In all honesty. I can. And the idea of doing math on a live stream where I'm going to be wrong, because I'm bad. I'm not good at math. I have no problem doing it, but it's just going to take me a lot of time, and sets me up for comments on what I have to take. Oh, I see. You want a permanent setup. I'm replying to Carrie again. How long in feet is that roll-up J-pole, Carrie? Let's see. Oh, good. Okay, so I did get positive result. People want to see the office. Okay. Carrie, are you a math teacher or an English teacher? Because if you're a math teacher, that's very funny. I can't remember. Sorry. Okay, I'm making a note to do a Shaq video. Anyone see the radio in the Netflix? Yeah, I heard there's a radio in the Lost in Space. Like, there's Morse code, right? Yeah, exactly. I'll have Zach there correcting my... I could just have Zach be on the any of the episodes that has math. Just let him talk to everybody. Robert, awesome radio, many dollar. My this one, this guy, yeah, many dollar, many dollar. Yeah, James, you're right. From what I understand, the math used in extra is just something you yeah, it's like anything, because it's multiple choice. You're just looking for the answer to the question. You just remember the question, boom, there you go. Tom says, the extra classic exam has me wanting to start doing crystal meth and cutting myself. Yikes. Jesus. Yeah. Well, there you go. Carry. It's... No, I mean, half wave. Now you're making me do the math. I mean, how long is it lengthwise? I want to know, is it just something you can go down to the store and buy a wooden dowel and just stake it to a wooden dowel on the tip and just put it on a tripod? Or just bolt it to the side of your house? That's what I would do. Get one of those TV antenna bracket mount things. Take a wooden pole. Just paint it. Just paint the whole thing with like exterior paint. Something real, like spray can. Real thick though. put an eye bolt in the top of that, drill a pilot hole with an eye bolt, hook that antenna on there, boom. This radio is an ICOM 7300, which is $1,200 to $1,300 brand new. Yeah, Daniel, you bring up an interesting point. I as because I'm a libertarian. I'm a pretty pro freedom guy. I think that the test doesn't solve a lot of problems. I don't think it does. I don't think it creates more intelligent operators necessarily. I don't think it creates better operators, because ultimately you're going to forget 90% of the stuff. You're going to forget the majority of the stuff that's in the test anyway. So it's better if you just get people out there learning, make it really easy for people to find other people like Elmers and clubs, and get people exposed that way. You know, there's so many things on YouTube now that are generally gonna... There is one positive side, is that people could get hurt. Like, there's actually some stuff here that people can get hurt. Like, depending on how much power you're putting into an antenna, and if you haven't set up right, or you're too close to it, or you're doing something, or you've got return power coming back in, you could get hurt, right? So, yeah. It's 1 meter long. Oh, okay. Yeah. I would attach that to... Carrie says the antenna that she has is 1 meter long. I would strap that to a piece of wood, even a 2x4. Put that on the side of the house and run your cable. And you can use it indoors, but it's not going to be as effective. Just keep that in mind. Dan, well, who asked me a question? I learned being on the job. Yeah, I'm an on the job kind of guy too. Satfan asks, is there any restrictions on how tall an antenna can be? Yeah, it depends on where you live. There are what do they call those? Home. When you live in a gated community, they've got the homeowners association, HOA. Some say no antennas, no amateur radio, period. I saw that on the Ham Radio Crash Course. Somebody posted some Bill of Rights that they had in their HOA, and I was like, that's illegal. So there's a parity act that's, I think, in the Senate or the House that would say that you are allowed to put up an antenna. There's not zero restriction, but you're pretty much allowed to do so. In Cerritos, you're not allowed to go higher than 20 feet above the highest point of your roof line. So my antenna is on a mast at roughly 19.9 feet above the roof line. Oh, sure. Yeah, and some things like airports and some other things, there are other restrictions. Because if it gets too high, you know, they think a plane's going to clip it or something. Daniel says, in my state, the local clubs don't exist anymore, and nearest thing... Did you check the ARRL website, and are you sure of that? Yes, and I Love Lasers says, since we're considered an emergency service. Yes, that's why the Parity Act exists. That's why you are allowed to have an antenna, is because we are considered a service for emergency communication. So they can't really stop us from doing that. FN Dude, I was late. What was the beverage tonight? Just rocking a Shinerbach. The beverage was, and I'm not done with it yet, Firestone Sukaba, which is a barley wine ale. 12.5%? Yeah, 12.5%. Pretty strong. I'm not going to need much more than this. Yeah, at a certain feet you have to light on it, and they want to paint it red and white in some states, I believe. HOA, I live in a mobile home park that has HOA, but I am on the committee that says yes or no. I said yes, as did my neighbor, who is also a ham. Sad fan, I'm in Lancaster, CA. Would I have to ask the city? Absolutely. Oh, you are an HOA? Or non-HOA? Yeah, I'd check, but Lancaster, from what I understand, you can do pretty much whatever you want. Bummer about the clubs, Daniel. Yeah, it sounds like you don't have in your area. Wow, we almost went 2 hours on this one. Gosh, who's going to watch this thing? Okay, I don't want to tap out too early, so I'm going to end it here, and I'm going to hop over to Discord and continue to talk. Let's see, what else do I need to do? Yes! Thank you to the patrons! Carrie and Michael and Terry and Jason and Franklin and Henry and Danny, Von Dubs, Chris. David's a new patron. Thank you, David. And, of course, the Brew Crew. These are the producer level patrons. We have a $1 level patron. All patrons get access to the newsletter, which I put out once a month. It's a full color newsletter with pictures and all kinds of fun, interesting things about my thoughts of ham radio. So if you're interested in that, check out the link in the description. That's going to do it. Yeah, that's going to do it. 40 meters doesn't look very busy on... Yeah, 40 meters is dead, dude. Let's see what 80 looks like really quick. 80 is way more busy. Way more busier. What was that booming station? Oh, it's a Spanish speaking station. Let me turn it over here. Sounds good. Doesn't that sound good? Love it. All right, that'll do it, guys. Thank you so much for watching. We'll talk to you again next week. Videos coming out this weekend for Emergency Comms, so look forward to that. Most likely Sunday. Okay, thanks a lot. See you.